All right, our next lesson is going to be lesson 1.4, which involves the perimeter and area of a couple different polygons in the coordinate plane. So, with those, we need to actually identify a few concepts. And the first one is what a polygon is. Okay, and a polygon is it's a geometric figure and there's a number of things that we need to make sure that that we establish about a polygon. It is composed of a minimum of 3 line segments, meaning that we cannot have any curves in it. Okay? Each side intersects exactly 2 sides. Okay? And at each there is a vertex. So a few things in terms of what is a polygon and what is not a polygon. So, you know, again, my software can make these things straight, but the following is a polygon. Notice that we have line segments, okay, that are all going to attach to each other. But this is an example of one that is not a polygon. You guys ready? Here, this guy right here is my issue, that little overlap. So that guy is not going to be a polygon, all right? Further, I might have a polygon. And again, this is a polygon. It's composed of line segments. Doesn't maybe look like your traditional polygon, but where we have issues is when people want to do something like this, is if I were to have like a curve, okay, this guy is going to be a no. So that it has to make sure that you have to make sure that you have all line segments, okay? So it intersects with exactly 2 sides. That's one of the issues here. This guy with that overlap up top doesn't intersect with exactly 2. We're going to classify polygons real quick. So we're going to go by number of sides. And then we're also going to have the name of the polygon. And so we're going to have 3, 4, 5, 6, 7, 8, 9, 10. And we're going to stop at 10, okay? Actually, let me go back up here. So with 3, you guys know that as a triangle, okay? Next, if you have 4 sides, it's not just a square. A square is a specific instance of a 4-sided polygon. What we call that is a quadrilateral. Quad, right? So that being 4, like some of you guys are aware of, if you drive a quad, that's you know, that's a 4-wheeled. It's a 4-wheeled kind of motorcycle. People are familiar with, you know, the quadricep has 4 parts to it, okay? And we have 5, which is going to be the pentagon, okay? Penta is the root word that gives us 5. 6 is the hexagon. 7, I often hear students talk to me about septagons. That's weird. I don't know what a septagon is, like septic or, you know, tank or something like that. That's strange. It's not what it is. It's actually called a heptagon, okay? So that's your 7-sided polygon. 8 is an octagon, okay? Stop sign, right? 9 is a nonagon. And 10 is a decagon. Now, what happens after that is there are n sides, and we call that an n-agon. So after 10, mathematicians kind of divorced from, and there are names for these things. There are Greek prefixes that can give you each of these. For example, the 11-sided figure is called a hendecagon. But mathematicians agreed that that's really not the important thing, is to be able to identify linguistically what all of those roots are. The important thing is just to be able to identify something as a polygon. So after 10, you can say 11-agon, 13-agon, 50-agon, and so forth. So we're good after that. One, just two more, because you will hear these: 11 hendecagon and 12 is dodecagon. But you don't need to commit those to memory. These right here, you must memorize. Okay? Make sure you know that, because this is going to come up in your quizzes. I'll ask you about the perimeter of a nonagon, and students are going to be a little puzzled about where to even start with that. So let's go back up here. I said that this guy here is a polygon. Well, how many sides does he have? Let's count them. He has 1, 2, 3, 4 sides. Okay, so technically that makes this guy a quadrilateral. He kind of resembles what's actually called a chevron, but he is a polygon. It just doesn't look like the one that you're used to as a quadrilateral. I think some of you are used to seeing a square, and that's the default quadrilateral in your mind. That is because there's a concept we need to differentiate, and it's the idea of being concave versus convex, okay? So concave, I think and this is the way I learned this, and it's the way I still kind of think about it, and I think about something being caved in. So if you thought about, you have your traditional, in your mind, the traditional polygon looks something like this, right? That kind of resembles a square. But if I were to kind of like punch in the side of it, right? This guy is convex. Okay, this guy here being concave. But there's got to be a better definition than if like it's punched in. And this is what it means. It means if you're going to take a diagonal, and a diagonal connects two vertices. And if I were to take a diagonal, right, it means that it will not go exterior to the polygon if it is convex. For example, so any of these. So here's a diagonal, here's a diagonal. Those all remain interior, okay? So here's a diagonal, we're good. That's interior, but watch, there is one diagonal, this one outside here, that is exterior. And because of that, that's what makes it concave versus convex. So there is the diagonal test. Okay? So, starting to imagine the world, I want you to look around the space that you're in and even examine the outline of one of the walls, including where there's a doorway. I think typically when we look at a wall, we think, oh, that's going to be a rectangle, but that's just not the case. If you examine all of the lines, you have to count all of those segments as individual sides. If there's a doorway on some wall, right? Well, that's of course not a rectangle. Look at how many sides I have here. 1, 2, 3, 4, 5, 6, 7, and 8. This would make this an octagon, but moreover, this would make this convex or concave. Concave, of course, because here, this vertex to this vertex would occur exterior to the polygon when I perform the diagonal test. All right, so a few things. Let's actually talk about perimeter and area, okay? Let's first talk about perimeter, which is oh, goodness. So perimeter, which is the length around a figure. Well, to do that, let's actually work in the coordinate plane. So let's find the perimeter of triangle ABC. By the way, you will see this, rather than seeing the word triangle written, you'll see the following. Mathematicians have agreed that what we can do instead to shortcut the word triangle is literally draw a little miniature triangle next to those three vertices. That's going to determine it to be a triangle. So we have ABC with vertices A is -1, 4. B is 2, 4. And C is 2, -1. Gentlemen, when you finish this problem, I do not want you to graph. You're not going to graph this. If you graph this, it shows me you don't know necessarily how to complete this problem. What I need instead is I need 3 lengths. I need to find the length of AB, that segment. I need to find the length of BC. And I need to find the length of AC. The only thing I would maybe graph is showing that I have triangle ABC. But there are 3 sides to that triangle, and I need to calculate what each of those is. And I do not graph it. Instead, what I'm going to use is the distance formula. So knowing that I'm going to take the square root, I'm going to take the difference of the y's, 4 minus 4 squared for AB, and the difference of the x's. Doesn't matter which one you do first, okay? 2 minus 1 squared, okay? That's going to equal 0 plus, right? 4 minus 4 is 0, squared is 0. 2 plus 1, right? 2 minus 1, which is 2 plus 1, is 3 squared, which is 9. Or in the square root of 9 is equal to 3. So that's one of my lengths. For BC, I'm going to take the difference of the y's, -1 minus 4 squared, plus 2 minus 2 squared. Again, I'm going to get a similar sort of thing. -1 minus 4 is -5. Squared is 25. 2 minus 2 is 0. Squared is 0. And the square root of 25 is equal to 5. Okay? And then last but not least, I have AC. And this one, we're not going to get as clean of an answer. But remember what you learned, you're going to leave your answer as a radical. Even if the textbook shows a decimal, the textbook is wrong. I want you guys to leave your answers as radicals right now. So I have AC, I have -1 minus 4 squared plus 2 minus -1 squared. Okay. What's that going to give me? Well, -5 squared is going to be 25. Plus 2 plus 1 is just 3 squared is going to give me 9. The square root of 25 plus 9 is going to be equal to the square root of 34, or rad 34. Gentlemen, that is not a perfect square. If you take the square root of 34, it's going to yield a non-integer answer. It will yield a decimal. So remember, in order to find the perimeter, I have to take the sum of all three of these segments. In other words, that's going to be the sum of AB plus BC plus AC, which is going to be 3 plus 5 plus the square root of 34, or rad 34. Gentlemen, the only two terms that I can combine here are 3 and 5, which gives me 8 plus the square root of 34. That is your answer. Leave it like this. Okay, I'm going to put this note here again. If you convert the radical to a decimal, you will lose credit. I'm actually asking you to do less work. It's one extra step to punch the square root of 34 into your calculator, get out a decimal approximation, and then add it to 8. That's a problem. Don't do that, please. Okay. I think that it doesn't take much imagination to do any polygon for perimeter. Because all you have to do, for example, with a pentagon, you would just add 5 segments together. And sometimes things just don't combine. Your next step, or your next thing, is we're going to do an area problem. So we're going to do 2 area problems together. We're going to find because we have 2 different formulas. We're going to find the area of triangle, triangle ABC with vertices where A is 1, 3, B is 3, -3, and C is -2, -3. First thing I want us to determine here is what type of polygon is this? And this is a triangle. So the area of a triangle is equal to 1/2 of the base times the perpendicular height. Okay. So we need to make sure that we can find here is I'm actually going to sketch this in a coordinate plane just to give me some sense of what's going on. A is going to be 1, 3. Excuse me. B is 3, -3. And C is -2, -3. A, B, C. So, if I were to graph this guy, right here is going to be my base. The height is what I need to figure out, which is right here deductively. But we know through effectively through a counting principle, we just know that this length right here is going to be 6. Later on, I'll show us how to calculate that in the instance that that height isn't perpendicular to a vertical line. So we know that that is 6, which is our height. So our base, right, which again, we can use the counting principle here, is going to be 5. Okay, so I want to find my area, which is equal to 1/2 of my base, which is 5, times my height, which is 6. And in this case, 1/2 of 5 times 6 is 15. And this is going to be units squared. So area right now, we're not going to get too fancy on you because we haven't taught you enough in terms of calculating the line and the distance, but when it's perpendicular. So these problems actually should be pretty straightforward for you guys. I'm going to do one more, but use a quadrilateral. So we're going to find the area. Oops. Oops, it's jumping all around here, of ABCD. If A is 2, 2, B is 3, -1, C, oh, excuse me, I'm sorry. Let me go back here. Let me change these up a little bit. Sorry, this is going to be -3, 3. So you're going to have to erase a little bit in your notes. That's why it's a good thing that you're using pencil right here. This guy is 3, 3. C is 3, -1. And D is -3, -1. Now, if I asked you to find perimeter, it's different. I mean, you're going to have to calculate the distance of 4 sides and then add them all together. But remember, the area of a rectangle, which is effectively the thing is the area of a square, right? If you recall, is going to be length times the width. Or LW. And of course, for a square, length is equal to width, which means that it's going to be length times length, or width times width. Or in other words, we just say the side length squared, okay? So let's go ahead and sketch this guy in a coordinate plane. So for the area problems for right now, I want you guys just to sketch it in a coordinate plane. Okay, -3, 1, 2, 3, up 3, 1, 2, 3. We have +3, 1, 2, 3, up 3. So this is A, this is B. C is +3, down 1. And D is -3, down 1. And of course I can connect my dots here. So again, AB, we're going to use a counting principle. This guy is going to be the width, which is going to be equal to 6. And the length, how tall is it, is going to be equal to 4. So super straightforward. Area is equal to length times width, which means it's equal to 4 times 6, or in other words, 24 square units, or units squared. Please find lesson 1.4 and go ahead and get started.